Beneath that warm glow lies a wild, unpredictable force that scientists are just starting to figure out. Ever wonder why the sun acts in ways we can't fully explain? What hidden dangers are lurking beneath its surface, and how close are we to a major disaster? In this video, we're diving into the jaw-dropping truths about our closest star, stuff they never taught you in school and that science is still racing to understand. From magnetic storms that could knock out power worldwide to solar events that seem to break the rules of physics, the deeper we dig, the scarier it gets. Stick around till the end because what you're about to learn might totally change how you look at the sky. When you were in school, you learned that the sun is a ball of burning hot gas. That's true. But it's also a massive oversimplification. Scientists have been studying the sun for centuries and they still don't know exactly how it works. But they have learned some pretty amazing things about it. Like, did you know that there are parts of the sun that are actually solid? Yeah, I didn't either. But according to NASA, there is a small inner core that is as hard as steel. No wonder Captain America's shield is made out of it. Okay, maybe not that particular one, but it does make up some of the material. But this inner core isn't the only thing that makes up the sun. There's also an outer core and a radiation zone. But those aren't exactly what you think either. The outer core is actually a liquid, which makes up about 21% of the sun's total mass, but the radiation zone isn't like anything you've ever seen before. It's a plasma, which means it's a mix of gas and electromagnetic radiation. But if the sun is so big and hot, why hasn't it just burnt itself out already? The answer lies in another mind-blowing fact. Did you know that the sun is mostly empty space? Yeah, that's right. Most of the sun's volume is taken up by a glowing ball of plasma. But don't let that fool you. This plasma is incredibly dense. In fact, it's so dense that if you could squeeze it down to Earth size, it would weigh more than 10 trillion tons. But here's the kicker. Even though the plasma is so dense, it's still mostly empty space. That's because the particles in it are spread out over a huge area. So even though they're close together, they're not actually touching. So if you wanted to take a walk on the sun, you could probably do it without getting burnt. Just don't get too close to the surface or you might trigger a solar flare and burn up in the process. You may not realize it, but the sun has a lot more going on below its surface than meets the eye. Beneath the photospheric layer, which is the part of the sun that we can actually see, lies the convective zone. This is where plasma flows in giant cells, each around 100,000 kilometers wide, like boiling water on the stove. These cells circulate energy throughout the sun and play a major role in driving the solar activity we observe from Earth, but it's what lies beneath the convective zone that's truly mind-boggling. At around 700,000 kilometers deep, the plasma suddenly becomes incredibly calm, almost eerily silent. This is the radiative zone, a mysterious layer of the sun that extends all the way to the core. Here, energy is transported by radiation instead of convection, meaning that photons can bounce around for thousands of years without moving more than a few centimeters. This is a strange and almost alien-like environment, far from the churning plasma of the convective zone above it. And while scientists have been able to study this zone indirectly, they still don't fully understand its complexities. One thing's for sure, though, the radiative zone is a crucial part of the sun that plays a key role in powering our entire solar system. So next time you look up at the sun, remember that there's much more going on beneath its surface than meets the eye. We've barely scratched the surface of what we don't know about the sun. There are so many secrets hidden beneath its shimmering light that it's hard to know where to start. But luckily, NASA and other space agencies are working hard to unlock them. One of the most fascinating aspects of the sun is its corona, the outermost layer of its atmosphere. The corona is where many of the sun's most dramatic features occur, like solar flares and coronal mass ejections, which can send billions of tons of plasma hurtling towards Earth. But it's also home to something else that's equally amazing: coronal loops. These are giant arches of plasma that extend thousands of kilometers from the sun's surface. They form when magnetic field lines connect sunspots and can remain stable for months. But what's even more surprising is that these loops often contain a second smaller loop within them, like a set of Russian dolls. But unlike their simpler cousins, the inner loops are constantly shifting and changing shape, creating a mesmerizing display of solar activity. And if that weren't enough, add solar tsunamis into the mix. That's right. Just like earthquakes can cause giant waves on Earth, Massive eruptions on the sun can generate enormous waves of plasma that travel across its surface. These solar tsunami can reach heights of over 100 meters and last for hours. But they're not just a pretty sight to behold. They also remind us of the incredible power of our sun and the potential dangers it poses to our planet. Take, for example, sunquakes, which are literally earthquakes on the sun. These mysterious events are thought to be caused by the sudden release of energy in the sun's atmosphere, creating seismic waves that ripple across the star. But that's not all. Sunquakes can also be triggered by solar flares and coronal mass ejections, making them a key indicator of the sun's volatile nature. When these events hit Earth's atmosphere, they can cause auroras and disrupt important systems like GPS and communication networks. And then there are solar storms. These are intense bursts of energy that can wreak havoc on our planet's magnetic field. When a solar storm hits Earth, it can cause widespread blackouts, damage satellites, and even endanger astronauts in space. So it's no wonder that scientists are working tirelessly to understand the sun better and predict its behavior. With new technologies, like NASA's Parker Solar Probe, we're finally able to venture closer to the sun than ever before. By studying the behavior of plasma as it whips around the star, scientists hope to unlock the secrets of solar storms and other eruptions that threaten our planet. It's a thrilling frontier of space exploration that promises to reveal the truth about the sun and our place in the universe. Understanding the sun and its behavior is crucial for our survival on Earth. From the energy that powers our planet to the communications that connect us globally, our modern world relies on a stable and predictable solar environment. When the sun acts up, sending out massive bursts of energy or coronal mass ejections towards Earth, it can disrupt critical infrastructure like our power grid system. These disruptions can lead to widespread blackouts and chaos for our society. Imagine a world without electricity for days, even weeks at a time. It's a scary thought, but it's a real possibility if we don't understand and prepare for these solar storms. It's not just our power grid that's at risk either. Are increasingly reliant on satellites for everything from GPS navigation to internet connectivity. Solar storms can damage or destroy these satellites, leaving us without the technology we depend on. Astronauts in space are also vulnerable to the sun's fury. When a solar flare erupts, it can endanger astronauts on the International Space Station or other spacecraft. These eruptions can disrupt their communications and even damage the spacecraft itself, putting astronauts' lives at risk. But it's not all doom and gloom. By understanding the sun better, we can develop better ways to protect ourselves against its negative effects. For example, by monitoring solar activity, we can predict when a solar storm is headed our way and take steps to mitigate the damage. We can also develop new technologies to shield our satellites and spacecraft from the sun's radiation, keeping our astronauts safe on their missions. As we continue to explore the sun, we'll uncover even more secrets that they never taught you in school. The truth is that our understanding of the sun is constantly evolving as new discoveries are made. With the launch of new space probes like NASA's Parker Solar Probe, we're now able to venture closer to the sun than ever before. This mission is just one example of the incredible feats of engineering and scientific curiosity that are driving our exploration of the solar system. As these missions continue to unlock the secrets of the sun, we can expect to learn even more about the incredible forces that shape our planet and our universe. So keep looking up at the sky with wonder and curiosity, because the more we learn about the sun, the more we uncover the truth about our place in the universe. Who knows what other amazing discoveries await us as we continue to explore the final frontier. Videos like this take time, science, and just a little obsession. If you found something fascinating here, don't just watch and scroll. Hit that subscribe button and help Science Beyond the Lab keep bringing you the stories that mainstream science ignores.